So we're going to do a related rates video. We're going to figure out how do we tackle these related rates problems. So I have the steps written out here as to how to solve these related rates problems. The first thing you ever want to do is find the main equation. Then you want to take the implicit derivatives and then plug in. But like I said right here, but first you have to know what to look for. You got to know what is the question asking you to do, what are your given variables, and what are the variables that you have to find. So let's read the problem together so we can figure out what this question is asking us. And in this video, we're only going to tackle part A for now, and we're going to do that, and we're going to only use this first input. So it says I'm moving a ladder 25 feet long, so we can see that right here, is leaning against the wall of a house. So this is the house. And the base of the ladder is pulled away at a rate of 2 feet per second. So this base right here, let's call that x, is being pulled at 2 feet per second. So how fast is the top of the ladder moving down the wall when its base is 7 feet, 15 feet, and 24? But we're only going to do 7 feet for this example. So know what to look for. So what's our given here? So it tells us that a ladder is 25 feet. So that's just the length of it. We also know that this ladder is somewhat of a triangle. And it reminds us of the Pythagorean theorem, doesn't it? Because this is a right angle. So if we label this as x and this is y, we can get x squared plus y squared is equal to, and then our length c, which is 25, and squared. So that's one thing we can figure out. And then the other thing we also learn is that the base of the ladder is pulled away from the wall at a rate of 2 feet per second. So if x is changing at 2 feet per second, that means dx dt, so the change of x over time is 2 feet per second. So then the question asks us, how fast is the top of the ladder moving down the wall? So the top of the ladder, which is this point, represents our y coordinate because we just mentioned this side as y. So if it's asking at how fast is the y changing with respect to time, so it's basically telling us to find dy dt, which is the change in y as time passes on, right? So now that we found our main equation here and we knew what to look for, let's take our implicit derivatives. So let's write out our main equation here. I'm going to scroll down. We have our main equation, which is x squared plus y squared equals 25 squared. And if we take our derivatives, this will be 2x times dx dt, because of chain rule here, plus 2y dy dt. And then we take the derivative of a constant. This gives us 0. So we want to isolate for dy dt. We want to get dy dt by itself so we can solve for it. So let's move this bad boy over here. And we get 2y dy over dt is equal to negative 2x dx over dt. Now let's divide by 2y on both sides in order to get dy dt by itself. So we get dy over dt is equal to negative 2x over 2y times dx over dt. And these simplify to negative x over y dx dt. So now we found our equation for our implicit derivatives. So we can plug in now. So first, we plug in for our x. We know our x for this. Actually, do we know it? What did I just say here? We have an equation of x squared plus y squared is equal to 25. And our given is that x is 7 feet. So that's a second given that we had, is that x is equal to 7 feet. So that's our plug-in for here. Now, the thing is, we also have a y here. And so in order to solve for y, we have to use this main equation again. So we're going to do, if we have 7 feet for x squared plus y squared, right? This gives us 25 squared. So if we have y squared is equal to 25 squared minus 7 squared, if we take the square root of both sides, we get the square root of 576. And this gives us an answer of 24. So now we have an x, we have a y, so we said x equals 7, and we have a y, and we have a dx dt, which was 2 feet per second. So we have dy over dt is equal to negative, and we got x, which is 7, y, which is 24, times 2, which is dx dt. So this gives us negative 14 over 24, which simplifies to negative 7 over 12 feet per second. So this means that as x moves away at 2 feet per second, our y coordinate is changing at negative 7 over 12 feet per second. So that is part A for you.